All right, so purpose of this seminar is to educate architects, engineers, other specifiers about the benefits of utilizing hot dip galvanized steel on a myriad of projects throughout North America. You'll also be able to differentiate hot dip galvanizing from other zinc coatings. Sometimes we get confused with those. And then, of course, recognize positive environmental and economic contributions to the goals of sustainable development, which is critical in the world today. Learning objectives, like I mentioned, differentiate hot dip galvanizing from other zinc coatings. Identify reasons why specifiers choose galvanized steel. So first and foremost, corrosion protection, but we'll also go into durability, availability, versatility, and aesthetics. And then understand factors that affect hot dip galvanizing steel performance in various environments. And also that goals of sustainable development, both environmentally and economically viable for hot dip galvanized steel. Just a little bit about the AGA, or the American Galvanizers Association. We represent over 172 hot dip galvanizing plants in North America, Canada, US, and Mexico. Over to 76 member companies. We provide technical support on design, inspection, specification of hot dip galvanized steel. So if you guys are ever working on a project or have any questions, feel free to use us as a free resource. Provide marketing material for our members, and then specifiers, once again, that free resource for specifying hot dip galvanized steel. All right, so first and foremost, we will talk about structural steel, how it's reliable, resilient, and recyclable. Since I think everyone's on the call right now, and before we really get into the nitty-gritty, I just want to mention on these slides, anytime you see one of these mouse icons, it's clickable. So you can just it takes you right to our project gallery about that project. So pretty much every page or every slide has a link on it to either a publication, case study, or anything like that. So just FYI. All right, so structural steel. So let's talk about why it's reliable, resilient, and recyclable. Reliable, well, it's readily available. Steel is one of the most common building materials out there. It is cost effective. Galvanized steel is a quick turnaround time, so you can have something built as galvanized and built as quick as 8-12 hour turnaround time. Accelerated construction schedules as well, so just saving costs in time. It's highly resilient too. It does have a high strength to weight ratio of that of concrete, about 1 to 6. It's highly adaptable too. So future expansions are super easy to do on existing hot dip galvanizing structures. This also gives you more design freedom with aesthetic advantages. We're starting to see more architecturally exposed structural steel with galvanizing as kind of a focal point of the project. And then it is the highly, highly recyclable. Pretty much most recycled material in the world is steel. About 99.7% of all steel is recycled. Zinc is about 80% of all zinc that is available is recycled. So both zinc and steel have super high reclamation rates. So it truly makes it a cradle to cradle material. A lot of building materials will be cradle to gate. This is truly a cradle to cradle because once it hits the end of life, zinc and steel can be fully recycled without any loss of properties. All right, so first and foremost, why do we coat steel with zinc? It is for conquering corrosion. Corrosion is just costly. A recent study by NACE International, they were formerly known as AMP, estimated the global cost of corrosion at $2.5 trillion. That's about equivalent to 3.4% of the global GDP. 56 or 659 billion alone in US and 56 billion in Canada. So other concerns with corrosion obviously are waste of natural resources, potentially hazardous situations. We've seen some recent bridge collapses. Obviously our infrastructure needs work. Those potentially hazardous situations obviously have indirect costs as well. Obviously you're going to have to rebuild that bridge, rebuild the street, so that sort of deal. Usually those indirect costs are about 5 to 11 times the direct cost of the project. So pretty costly. And then also you're going to hear public outcry. We've obviously heard it in the news. And nobody wants a negative attention towards, what they built. So that's why we have protective coatings. Now, not all are created equal. Definitely have to consider performance, cost, sustainability, that sort of thing, and we'll dive into those a little bit deeper. I kind of sprinkled throughout a couple cool case studies that we have featured, a couple of our excellence awards in the past years that I will sprinkle throughout this presentation. This is a Metrolina greenhouse expansion. This is actually it was built in 1972 with hot-dip galvanized steel, but they've actually expanded since then. And now it covers over 200 acres of greenhouses under one roof. It's actually the largest single-story structure in the United States. And since 1972, they've chosen to hot dip galvanizing every single structure and every single component they can. Just because it protects the outside from the outside elements. A pretty humid climate in North Carolina, so obviously protecting against that. But then it also protects against the inside of the greenhouse. All the pesticides, fertilizers, chemicals they're using to treat the plants. It's actually going to protect the inside as well because it's a full immersion process. So all that part of the galvanized steel gets covered. All right, so we're going to go into the hot dip galvanizing process. It's just good to know the actual process. This is mostly for, galvanizers to control and everything, but being a specifier, it's good to know the process and kind of helps you design better for it. All right, so this is the overview of the galvanizing process. It goes through a series of surface preparations. So cleaning the steel, because this steel has to be cleaned in order to react with the zinc. It's dipped in that zinc bath and then it's cooled and inspected. So overall, pretty quick process. Surface preparation is absolutely necessary as zinc will only react with the clean steel. When the zinc gets dipped in the hot, or when the steel gets dipped in the hot zinc, it actually has a metallurgical bond and fuses together. So it needs to be clean in order for that to happen. Goes through three cleaning solutions, degreaser, dirts, oils, organic residue, chemical cleaning, mill scale and oxide, so rust. And then fluxing is actually two things. Mild cleaning gets off anything that is left on there. And then also puts on a protective layer. So while that piece is waiting to go into the zinc bath, it's not picking up anything. Because once again, unclean areas will not grow that zinc coating. And then comes the actual galvanizing process. Steel is fully immersed in a bath of molten hot zinc, about 830 to 850 degrees Fahrenheit. Bath chemistry per ASTM specifications has to be at least 98% pure zinc. Most every galvanizer I know out there is running more like 99.5, 99.6% pure zinc. Up to 2% additives include aluminum, bismuth, and nickel. Have no effect on the coating whatsoever, mostly just the fluidity of the bath. Molten zinc reacts metallurgically formed bonded coating, and then the reaction is complete when the steel reaches the bath temp. So depending on how big the piece is, it could be as short as 2 minutes all the way up to about 15 is all. All right, here is a galvanizing video for you. Most of the time, the newer plants will have a completely enclosed kettle too. So it'll be entirely closed and then big metal doors open and the pieces move through. Right now, they're just kind of skimming away the ash, the dross at the top. And then, yeah, even these big ones, it's about a whole 10-minute process is all. And then as soon as they're cool enough to touch, you can erect it in that same day. Inspection is pretty simple. It's straightforward. Usually just a visual inspection with the naked eye, making sure there's no visual bare spots or anything like that. Coating thickness can be checked by a magnetic thickness gauge. And then we have a ton of stuff on inspection of galvanized steel products. We actually have a free inspection app for Apple and Google Play. You can download it at galvanizeit.org/mobile. Gives you a clear visual guide to all the surface conditions of galvanized steel. It's also great because it doesn't require service. So if you're on a job site out in the boonies, you don't have service, you can still use our full app. So definitely check it out if you're looking at galvanized steel. All right, so what is zinc? We get this question every once in a while, like, what is zinc? I've heard it's a heavy metal, but it's also a healthy metal. So we'd like to just kind of preface it by saying, it's natural, abundant, and it is essential to life. So what is it? What is zinc? Is just naturally found in the air, water, and soil. About 5.8 million tons of zinc are cycled throughout the environment annually, and it is the 24th most abundant element in Earth's crust. So pretty abundant. It is essential to life. Every single organism requires zinc in order to live. It is vital for cell division, crucial for growth of bones, organs, brain development, memory, sensory, cognitive, even strengthen our immune system. It is in literally everything from car doors to nails to sunscreen to makeup, lotions, cold medicine, everything. It's estimated about 500,000 people, mostly children in third world countries, are actually zinc deficient. And over 200,000 actually perish every year. So, IZA, the International Zinc Association, has teamed up with UNICEF to bring Zinc Saves the Kids. It's a great organization. And just $5 gets one kid a zinc tablet for an entire year, mostly in third world countries. So if you're looking to give back, check out Zinc Saves the Kids. I think it's just zincsavesthekids.org, or you can click on this link when you get it. This is a good quote from the IZA Material Supply Study in 2022. Zinc from recycled sources has doubled between 2010 and 2019, while zinc production from mined ore has remained almost constant. So that means we're doubling the amount of zinc recycling while, maintaining the same production, mining the ore out of the earth. So we're just getting more and more better at recycling zinc and steel. All right, now let's go into zinc coatings a little bit. They sometimes get mixed up with hot dip galvanizing, or everyone thinks a zinc coating is galvanized steel, and there are a lot of big differences. So from left to right, you're going to have zinc thermal spray. It's also known as metallizing. Hot dip galvanized steel, zinc rich paint, galvanized sheet, and then electroplated. You notice, thermal zinc spray and hot dip galvanizing are going to be the thickest. But hot dip galvanizing is going to be the most dense because it's actually a metallurgical bond that's fused together. Zinc thermal spray or metallizing is once again a mechanical bond. It's just going to sit on top. It's only about 85% dense as hot dip galvanized steel. All right, so we'll go into these just a little bit more so you can kind of tell the differences. Zinc thermal spray and metallizing is zinc wire or powder that's melted and then sprayed onto the steel surface. Shopper field, 85% dense as hot dip galvanizing and mechanical bond. There are no alloy layers. You don't get that mechanical or metallurgical bond. Zinc rich paint, zinc dust, and organic or inorganic binders. This is often falsely called cold galvanizing. There really is no such thing as cold galvanizing. Cathodic protection dependent upon the conductive binder, zinc particles in contact, and percent of zinc in the dry film. If you have any zinc-rich questions, you can contact KTA Tater. They usually have some pretty good paint information. Mostly we see zinc-rich paint used as touch-up material on galvanized steel, which we also have a huge touch-up and material information on the website. Continuous sheet and electroplating often get lumped into galvanizing because it's a similar process. It's continuous inline dip for sheet, strip, wire. Coating thickness and alloy layers are very minimal. Common products are G60, G90, Galvanede, Galvalume. Electroplating is pretty similar. It's just no alloy layers and a very thin coating of pure zinc, usually more expensive than sheet galv. If you guys ever have any questions about these, contact the Galv Info Center. We put a link in here, but they are the ones that do all the continuous galvanizing. All right, so why do specifiers choose galvanized steel? Well, we'll go over corrosion protection, durability, longevity, availability, versatility, and aesthetics. So first and foremost, it is that long-lasting corrosion protection. With galvanized steel, which is unique to it, is you actually get 3 layers of protection within one coating system. First is going to be barrier protection. Barrier protection just resists corrosion by isolating that steel from the environment. It is a full immersion process, so the insides of tubes, hollow structures, handrails, that sort of thing, the whole thing gets coated. So you're isolating isolating the steel from the environment, therefore slowing down corrosion. Cathodic protection. Now we know on the galvanic series of metal that zinc is anodic to steel and will sacrifice itself to corrode to protect the underlying steel until all the surrounding zinc is consumed. So then you have cathodic protection. Then on top of that, you have the zinc patina. Now the zinc patina is unique to galvanized steel because it develops naturally over, going through weathering cycles, wet, dry cycles. And this becomes zinc hydroxide and zinc carbonate build up on the surface and actually develop the zinc patina, which is impermeable. I can never say that word. It doesn't let water through, and it really, really slows down the corrosion rate. And the zinc patina can quickly develop as soon as a couple months up to a year. So that really slows down the corrosion rate of the overall system. But with one system, you get 3 layers of protection. This is a good cross section of the galvanized steel itself. I kind of like to show this. One, it's showing the abrasion resistance and how hard the galvanized steel coating is, but it also shows the actual metallurgical bond. So if you start at the bottom, you're going to see base steel, 100% iron, 159 DPN. DPN is diamond pyramid number. It's just the number that they give to assign the hardness of a substance. So the higher the DPN number, the harder the substance. If you notice the gamma, delta, zeta are all actually a mixture of zinc and iron. Gamma is 75-25, delta 90-10, zeta 94-6. But they all have a DPN hardness number of above 159. So actually making the alloy layers harder and stronger than the base steel itself. So it just gives it that extra abrasion resistance. And also you can literally see the metallurgical bond happening. So we've seen it a lot in zoos for the abrasion resistance, just with the dealing with the big animals. A lot of heavy, a lot of equipment too being banged around. So this is the Cincinnati Zoo Elephant Trek, completed in 2023. Over 170 tons, everything from the frame structures, window facings, holding areas. Obviously, it helps out with the abrasion resistance, but then, they don't have to worry about maintaining it. Galvanized steel doesn't require little to no maintenance through the life of the project. So, they don't have to worry about trying to move around animals, close down exhibits, or anything like that to maintain it or repaint or touch up and repair. All right. I mentioned it a couple times. You get uniform and complete coverage. Interior coverage of hollow structures. You also get the same thicknesses in edge and corners because the coating grows perpendicular to the surface. It is a chemical reaction, so it's growing the same everywhere, regardless if it's on a flat surface or edges or corners. And you also get fully coated threads as well, which are usually centrifuged or spun to remove all the excess zinc. This is a good example of some of the newer advancements in short span steel bridges. This is a Fort Wingate Bridge replacement in New Mexico, and this is the press brake formed tub girders. So they come pre-assembled, and it's kind of like a plug and play system. About 12,000 pounds each. But making it galvanized steel, they come pre-assembled and everything, and just kind of a plug and play. We're seeing a lot more of these, and then being galvanized steel, you're not going to have to maintain this whatsoever. All right, longevity in the atmosphere. We get this question a lot. How does galvanized steel last so long in pretty much any environment? And we like to point out that galvanized steel is a 150-year-old process. So it's been around for a while, it continues to get better, but we have tons of real-world data to go off of. A lot of times people will rely on salt spray testing as reliable data, and it just with galvanized steel, it does not accurately mimic real-world conditions because it doesn't allow the zinc patina to develop. And the zinc patina is critical in the longevity of the hot dip galvanized steel. So when you use accelerated salt spray testing, you're just not letting that zinc patina develop like it would in the real world. Therefore, it's going to give you not accurate readings. So that's why we came up with a zinc coating life predictor. We worked with Dr. Gregory Zhang, and we took extensive global corrosion data from the database, and we put a link in here. We collect all this data, and then we did corrosion rate was dependent upon temperature, relative humidity, rainfall, airborne salinity, sulfur dioxide concentrate, and if there's a sheltering condition existing. So when we took all this extensive real world global data and we put it in, we get the time to first maintenance chart. Now, once again, this is uh, time to first maintenance is defined as only 5% rusting of the steel surface. So 5% really, very minimal rusting of the steel surface. So off of all the real world data, we split it into 5 atmospheric categories: rural, suburban, temperate marine, tropic marine, and industrial. Now, ASTM requires on all structural steel at least 3.9 mils of zinc. Oftentimes it's a lot more, about 5, 6 maybe mils. But anyway, for sake of argument, we're going to say we have 4 mils of zinc on this piece, and we're building in an industrial environment. We can see we hit about year 75 before we see 5% rusting of the steel surface. Now, very well could be that 75 years it's already hit its design life. It can be fully recycled and built again. You might get out there at year 75 and realize that there is not 5% rusting of the steel surface. It can last longer. So it just kind of gives you an idea off of real world data just how long galvanized steel will last in building in some of the harshest in climates. We get this question about in soil, longevity in soil. It is more difficult to predict. There's just highly varying properties within soil. You can have changes within soil. You can have working between short distances, different soils. So like maybe a clay-like soil on one side of the street, a rough rocky soil on the other side. So it kind of makes it difficult, but there are primary and secondary factors for longevity in soil. And primary factors include chlorides, pH level, and moisture content. And then secondary factors are resistivity, temperature, and aeration. Once again, we used the soil chart. We built the soil chart off of all the real world data to estimate the full service life based on those primary factors. Once again, this is all available on our website. You guys can even download these as a PDF and stuff. But these are our soil charts. This is, once you have determined those primary, secondary factors of the soil you're using, you can figure out what chart you're on. So say we're working with low chlorides and a high pH. We're going to be on chart 3. Once again, right around 4 mils of zinc on the piece is acceptable to ASTM standards. So still anything in the red is going to be less favorable, anything in the green more favorable. So still red, you're looking plus 70 years or whatnot. So feel free to use these on our website. If you go to our website and just search soil charts, they'll show right up for you as well. Water, it is also difficult to predict, similar to soil. Just there's changes in water flow rates, impurities introduced. Primary factors are similar to the soil: pH level, agitation, aeration, temperature, polarization, any presence of inhibitors. Fresh water, you can, good rule of thumb is hard water is going to just be a little less corrosive than soft, just because of the added chemicals in soft. Seawater, you want to look at dissolved salts and passive compounds, and then a good rule of thumb is just lower the temp, less corrosive. We have a whole like marine and water page on our website with all of our examples. We're seeing more docks and marinas and stuff like that being built out of galvanized steel because it does well with water. We like this slide. I just kind of tried to sum it up for you if you take anything away. What is corrosive to hot dip galvanizing, and then what is really good performance. Corrosive are going to be your highs and low pHs, anything above 12.5, anything below 4. And then in contact with dissimilar metals, it's been done before. It's just kind of, you have to consider how much surface area is actually touching and in the environment. Most of the time, it's just best to isolate with a non-conductive material, a rubber, cement, paint, something like that. Good performance is chemically neutral solutions, pH level 4 to 12.5. Treated wood, stainless and hot dip galvanizing does great with treated wood. Hot dip galvanized rebar, reinforced steel. It is amazing. It actually protects the concrete from outgassing, sprawling, cracking. It's really great. We do a full rebar seminar as well, and you can find a wealth of information, but it does great in concrete. Extreme temperatures all the way down from -40 to 392 degrees Fahrenheit. And then with aluminum and stainless, except when you're off of like right off of the bay of salt water and air, that can accelerate some of that corrosion between aluminum and stainless. This is a good longevity project. This is the Frederick Myers Botanic Gardens. This is in Grand Rapids, Michigan. This was built and completed in 1994, so it's been over, yeah, about 31 years. Um, yeah, the entire structure is hot tip galvanized steel. We went out here in 2018, and it looked honestly the same as it was. We took some readings, and they were all 6+ mils on it. This is after 30 years in Michigan's weather, 9 feet of snow, 90-mile-an-hour winds. Also, kind of like the Metrolina greenhouse, they got to account for all the corrosion happening inside with the chemicals used to treat the plants, fertilizers, pesticides, that sort of thing. Talked to the architect when we were there, and yeah, he said that it looks the exact same that it was, and day it was erected in 1994. Availability, it is factory controlled. There are no humidity requirements for galvanizing, so it can be done 24/7, 365, rain or shine. A lot of galvanizers like to brag that they run 6.5 days a week. Galvanizers throughout North America. Average kettle is about 40 feet, although many of the bigger or newer ones are 50 or 60 feet. You'd be amazed at what they could fit in the kettle, even if it's larger than 60 feet. Sometimes they can do a progressive dip. They dip one half and then flip it around and dip the other half. Quick turnaround time, no curing time. As soon as that piece is cool enough to touch, you can erect it. Variety of pieces, intricate pieces, that footballer structure, that's all galvanized. And then all the way down to, fasteners, small parts, can all be galvanized as well. More with less, high strength to weight ratio of that of concrete. You can use about, yeah, 1 to 6 of concrete. Ease of expansion can be inventoried and stocked as well. It just lasts so long that a lot of times it'll just, you can sit in the stockyard and be just fine. It does have better seismic advantages than concrete. It's just more ductile and lighter. So it's just going to do well in earthquakes and that sort of thing. Modern natural appearance kind of gives that matte gray, non-reflective, uniform finish. So it kind of doesn't really take away from anything, blends in with their environments. We are seeing more exposed design elements, AESS projects, really using the steel arcs and trusses as part of the architecture. Now, if you're just trying to meet finishing requirements of AASTM A123, might not meet the aesthetic desire for AESS. So you just want to have an additional discussion with your galvanizer. Say, hey, this is an AESS project. They can help you out. We also have an AESS specifiers guide that we link to here as well. A lot of people ask about, natural weathering and like, when is it going to look all the same? Or, I have a piece and it was really shiny on one side and dull on the other. That happens. I mean, that's just, steel chemistry can play a part. A lot of different factors. Corrosion protection is still there. Nothing affects the coating. So we did a couple of examples for you guys. The top left photo was taken in December of 2022. That's newly galvanized right on that guardrail. And then photo was taken in March, so just about 3 months later, and it had completely weathered out. So it's all the same kind of matte gray. Same thing below. 2019 was taken, a new power line put in, and then about actually, yeah, 3 years, 4 years later, I mean, it looks the same. So it probably happened a little sooner than that. That's just when we could get the picture taken, but kind of gives you an example of just it'll definitely weather out within a few months. This is a great AESS project if you ever get a chance when you're in New York. Definitely visit the Monahan station. It is just absolutely gorgeous. Really uses the architect of the trusses and the beams as part of the architecture. It's just absolutely stunning. So definitely check it out. But it is all galvanized steel. So that is the kind of finish that you can get with an AESS project. Sometimes we need color. That matte gray isn't not going to cut it, so that's why we offer a duplex system. Duplex system is a paint or powder coat over galvanized steel. This can be done for many reasons, mostly aesthetic preference. Sometimes it's branding matching, like fitting in with the existing structure. Safety identifications, gas lines, something like that. A lot of times it's used for repairing existing structures as well. But what happens when you paint or powder coat over galvanized steel? You're actually getting a synergistic effect, and it provides both coatings 1.5 to 2 times the sums of the systems alone. And it extends the maintenance cycle of the paint, and you can usually drop one maintenance cycle of paint, and you'll never have to fully repaint. It's usually just touch up and repair. We have a full 1 hour long duplex seminar. Highly recommend you check it out if you want more. We have a publication as well on our website if you want more information on duplex systems. Here's a good example of a newer duplex system. It's the Highland Park Interchange project in Pittsburgh. Is completed in 2023. It's just like all large, small beams, column, galvanized, and then painted afterwards. Deliberate choice was made to paint over. These are used for sound barriers along the Algean River. The decision was made to not only enhance the corrosion protection because Pittsburgh it is corrosive, but also it aligned with the artistic vision of kind of making it look like the river itself. Trying to make the flow, kind of make it look like a little bit more than just a flat sound barrier. We'll just talk a little bit about steel's sustainability, and then we will go ahead and do a cost case study through our calculator, which is available on our website that you guys can plug in all your project parameters and get a nice readout and stuff of all the different coating prices. Anyway, so let's start with economic advantages. We know that iron and steel or iron and zinc are natural, abundant, and essential to life. Iron ore is the fourth most abundant element in Earth's crust, and zinc the 24th most abundant. Both are infinitely renewable resources. So both iron and zinc can be 100% recycled, multi-cycled without any loss of properties, and they both boast high reclamation rates. But virtually 100% of steel is recycled, and then about 80% of the zinc is recycled. Maintenance-free longevity as well. So once you build it, it's going to look good. You won't have to maintain it. You're saving money in the long term. And this is a great sustainable project. This was the Mr. Professor and Captain Trash Wheel. I'd probably say this is my favorite example we have in our project gallery. They are these boats, I guess, these galvanized steel structures that float around the harbors, and all they do is just pick up trash. So you can see the water wheel there. They become local celebrities. They have googly eyes now. There's actually a map you can look at where they're at. I think they've added 2 more since then, so I think they're up to 5 now. And since their debut in 2014, they've collected more than 1.5 million pounds of trash. So just a easy way to automatically, kind of clean up our harborways, easily. And then, these are going to require little to no maintenance with galvanized steel. Another really good sustainable project. This is the Howling Heat Recovery System, built in Mona, Utah in 2016. And so these huge columns were built adjacent to a power plant. And they actually use the heat and the CO2 emissions from the power plant to assist in growing the tomatoes. So the heat warms the greenhouse, and the carbon dioxide fertilizes the tomatoes. Complete win-win as it offsets emissions, help make the tomato plants more sustainable. And obviously, built with galvanized steel, you're going to not have to maintain this and stuff. So, really cool project. Hope this starts, we start seeing more of these around. All right, economic advantages, initial cost benefits. So we'll go over to overall material and application costs. And then you really do see the time savings in the construction because it's such a quick process. You also see life cycle cost savings. So that's just the total cost throughout the project life. And that's going to include the maintenance costs and time of value of money. So interest and inflation, which is important. Often hot dip galvanizing initial cost is its life cycle cost. We've seen on a lot of those charts and information that, even in industrial environment, you're looking at, 75 years before 5% rusting. So long time. So often it's an initial cost and you're done. You don't have to maintain it. So we did our life cycle cost calculator. It's 2 ASTM A1068, completely automated for you. You can visit lccc.galvanized.org to put in your project parameters. But we're going to go ahead and do one with everyone right now. And then, feel free to play around with the calculator later. So the initial cost parameters are going to be material and number of coats, surface preparation, cleaning methods, shop field application and labor. Life cycle parameters are maintenance costs on a particular cycle. So that's unique to the system and dictated by the manufacturer. And this analysis considers net present value and net future value. So inflation and interest. These are our data sources, NACE, KTA survey, and then we did a galvanizing industry survey as well. All right, so our cost case study project parameters, we're going to be looking at a typical mix of sizes and shapes. We're building a 50,000 square foot project, 70-year design life, and we're building in a moderately industrial environment C3. So this very well could be a parking garage, small stadium, petrochem plant, something like that. Surface prep and application are SP10 automated. Duplex would be SP16, and all coats are applied in the shop. All right, so this is what our handy dandy calculator spits out for the initial cost of the system. Right off the bat, you can see $2.16 a square foot for galvanized steel, all the way up to $8.33 a square foot for metallizing. So right off the bat, you're seeing you're already getting initial cost savings from the initial costs of the system. Now, if we go to 70-year design life cycle cost, full thing, hot dip galvanizing doesn't change because we know, it's not going to be 75 years before we see 5% rusting in an industrial environment. So we've already hit 70 years. It's done. We didn't need to maintain it once. So your initial cost is that. Every single other one has grown exponentially, except for the hot dip galvanizing and epoxy polyurethane. It is now $15.66 a square foot. So that is the duplex system. So you can see the life cycle cost savings between hot dip galvanizing on its own and also hot dip galvanizing in paint or powder coat because you're losing one maintenance cycle of the paint, you're extending the maintenance cycles of the paint, you lose a full repaint, so it just adds up over the life of it. So once again, I highly recommend everybody, taking the time, checking out that calculator on our website. Kind of fun to play around with. It gives you a print off of a PDF afterwards of all the coatings and stuff. All right, so in summary, why do we hot dip galvanizing? Well, it's just a 150-year-old proven process, proven performance, continues to evolve to get better. It's all natural, abundant, recyclable materials, so zinc and steel. Unmatched corrosion protection and durability, maintenance-free longevity, availability, versatility, aesthetics, environmentally and economically sustainable. All right, we have a markets website that is completely dedicated to our infrastructure. If you know, a few years back, the BIL, the Bipartisan Infrastructure Law, was passed, and that put a ton of funding, and we're actually finally seeing some of that money turn into projects. So this website, markets.galvanizeit.org, actually highlights all of the different parts of our infrastructure and then highlights within those of all the different components that can be galvanized. So if you know these couple little animations, all the blue imagery on there are what can be galvanized, and then you can click into there and click into more information on that. So definitely very cool. You'll get this link in the slide deck, but definitely check it out if you get a chance. Markets.galvanizeit.org. I will leave this up here for a little bit. These are just our AGA resources. We have a galvanizer locator, which is great. You just put in a mile radius and a zip code, and it'll give you contact information. It even lists their kettle sizes. So if you're looking for something big or small, technical assistance I mentioned, email us, call us. We are a free resource for North American specifiers. All right. Well, until next time, everybody have a great rest of your day. Thank you.